Just like adding and subtracting regular fractions where you need a common denominator, when we're looking at rational expressions, so fraction made up of numbers and letters, we still need a common denominator. So I'm going to look at all the denominators together and see what they all go into evenly. So my first denominator, I couldn't see it, but I understood that 3 wholes is over 1. My second denominator is xy. So whatever denominator I choose, it has to be at least xy big. It can't be smaller than that. Then I come over here, and because this is a y squared, my denominator has to have at least a y squared. I could just add a y squared at the end, but I already have a y there. So if I just make this y squared, I've made it big enough to accommodate the y squared in the original question. Xy squared is bigger than xy, so it will work. Now I'm going to compare all of my old denominators to my common one and multiply by what I'm missing. So for my first part, I had 3 over 1. In order to make that match my new denominator, I have to multiply the top and the bottom by all of it. So I'm going to end up with 3xy squared. And now all 3 fractions when I'm done should end up being over xy squared. So I'm going to write them, instead of doing 3 fractions all with separate bottoms, I'm just going to put them all over my common denominator. They're going to share this. I look at the next one and I have 4 and then xy. Well, to make xy into xy squared, I have to multiply it by y. So I have minus 4y. Now my last one, I have y squared, so it's missing the x piece. So I have to multiply top and bottom by x. So then I end up with plus 2x squared. And now this looks weird because we haven't really done a lot to it. We don't get a nice, neat, and tidy answer, but I've written it as one fraction. And sometimes when you're adding and subtracting, that's all you want to do. One denominator and a numerator that in this case just happens to have 3 pieces. But just as before, because we're dealing with fractions and the bottom or denominator represents division, I have to state restrictions. So I'm going to look at my common denominator and say, okay, x can't be 0 because 0 times any y squared would be 0, and y can't be 0 as well because x times 0 squared would be 0. We can also look at this when we have our bigger rationals, and just like before, when we're multiplying, I have to be able to factor these to compare my denominators. So x plus 1 over x squared plus 2x minus 3 becomes x plus 1 over x plus 3 and x minus 1, because two numbers that multiply to give negative 3 and add to give positive 2, minus x plus 2 over x minus 1, x plus 5. Two numbers that multiply to give negative 5 and add to give positive 4. Now I'm going to build my common denominator just like I did in the first one. So I'm going to look at my first rational, and my common denominator has to be at least as big as x plus 3, x minus 1. So it has to have both of those components. Now I come over to my next denominator and I'm going to compare. The denominator I use has to have an x minus 1. Well, we have an x minus 1, so I don't have to add in another one. It's not wrong if you do. You're just going to get an answer that's too big and have to reduce it. Then I look at my x plus 5. So my common denominator must have an x plus 5. When I look at it, there's no x plus 5, so I add it in. My two fractions are going to become all over one common bottom, which I've designed as x plus 3, x minus 1, x plus 5. I come over here and compare. X plus 3, x minus 1, I'm missing the x plus 5. And here's where you do need to be careful. I have to put it in brackets, and I have to think about this top as being in brackets as well. Because whenever you have a rational expression, there's implied brackets around the top and the bottom. Mathematicians are just too lazy to put them in there. So now this is going to become x plus 1, my old top, multiplied by x plus 5, because that's what I had to add in to the top and bottom. The sign in between them is a subtract. This top was x plus 2. Now I compare to see what I have to multiply by, and it's the x plus 3 that I was missing in order to make it into my common denominator. So now I'm going to multiply it by x plus 3. In this case, we absolutely can clean up our top. Once we factor those bottoms and find the common denominators, there's really no need to multiply that out. But I'm going to FOIL this, x squared plus 5x plus 1x plus 5. I took the x and sent it through. I took the 1 and sent it through. If this was a plus, I wouldn't have to be that careful. But because it's a subtract, I'm going to subtract all of these answers. So I'm going to leave my answer from this FOIL when I send the x through and the 2 through in brackets. So when I FOIL those, and by all means, if you are comfortable with foiling and you collect those middle terms together, you can do that. I just want to show you where all the numbers are coming from at this point. So I end up with x squared, subtract x squared, so it's gone. 5x plus x is 6x. Subtract 3x is 3x. Subtract 2x is 1x. 5 subtract 6 is minus 1. And now this is a coincidence. This doesn't always happen. But I did end up getting an x minus 1 and an on top and bottom. So I can cancel those as well. And I've emptied the top, so it's a 1. Can't be a 0 or else there's nothing left at all. Dividing anything divided by itself gives us 1. And my bottoms are x plus 3, x plus 5. That doesn't happen all the time. If my top ended up as x minus 2, then my answer would be x minus 2 over x plus 3, x minus 2, x plus 5. It's just because we did end up with the same thing on top and bottom. Can't forget my restrictions though. I'm going to go back up to this line here, and I'm going to find what would make each bracket equal to 0. I'm going to go in order from least, so negative 5 from this bracket, negative 3 from that bracket, positive 1 from that bracket. So those are the numbers that x can't be, or else there's a division by 0 in this question, and it can't be done.